Hi there, and thanks so much for joining me today for this video. So this video is part of our Module 10 series looking at one-way and two-way chi-square tests. All right, so in this video, I am going to go through the SPSS tutorial for one-way chi-square tests. Okay, all right, so let's get started. I'm going to go ahead and share my screen with you. All right. So as you can see, I have my SPSS open to the initial screen, and I'm going to go ahead and select open another file here, and open. And that's going to show me all of my data sets that I have. And because we are working with data that attempts to replicate Solomon Ash's study, I'm going to select ash.sav, and you can find this on the Canvas website. Just make sure that you download it and save it to your desktop or somewhere else on your actual computer before you attempt to open it. So then I'm going to click open. All right, and now I've got my my data set. So as I said, essentially what we are doing in the example in this tutorial is we're looking at a sample of participants who participated in a replication or an attempted replication of Solomon Ash's conformity studies in the 1950s. So in these particular studies, as many of you know, participants would be seated in a room with Confederates, and they would be shown a line, and then they would be asked to choose which length of line is correct from several different lines. So it was a fairly easy visual perception task. But what Ash did is he looked to see whether participants would choose the incorrect answer if all of the Confederates chose the incorrect answer, right? So would the fact that the majority of the people in the room with the participants selected a different answer pressure them to conform and select the incorrect answer? And ultimately what Ash found in one of his experiments was that as many as 75% of his participants conformed at least once. So they gave the incorrect answer that the Confederates had given, even when they themselves knew the correct answer. So again, Dr. Norrie, in our example data set, this is the sample of students that Dr. Norrie obtained. And essentially what we're looking to determine is if Dr. Norrie's results are similar to those of Ash or not, right? So just to recap, whenever we do a one sample or whenever we do a one-way chi-square, it's very, very similar to the one sample t-test in that we are comparing percentages in our sample to percentages in the population, right? So with both the one sample t and the one-way chi-square, we are comparing a sample statistic to a population parameter, right? But with a one sample t-test, we are looking at continuous variables. So we are comparing the mean, right? So the average obtained from our sample to the average obtained in the population. Whereas with one-way chi-square, we are looking at percentages or frequencies obtained in a sample of participants, and we're comparing that to frequencies in the population, right? So all of that is to say, I'll just pull up your your SPSS guide for today. And essentially what Dr. Mori is trying to determine is if people conform less nowadays than they did in the 1950s, right? So essentially what we're trying to do is see the percentage of people that conformed in Dr. Mori's sample and compare it to the percentage of people that conformed in Ash's original study, right? So again, a one-way chi-square is essentially the exact same thing that we did last week with the one-sample t-test. The only difference is a one-way chi-square tests a categorical variable, whereas a one-sample t-test looks at a continuous variable, right? So how do we know that this variable is categorical, right? Well, if we were to conceptually operationalize our variable as whether people conform at least once or not, right? We're going to have two levels of the category. Yes, they conformed. No, they did not conform, right? So those are clearly categorical levels, and this is a categorical variable because we're not dealing with any sort of quantity, right? So in this data set, no, they did not conform is dummy coded with a number 1, and yes, they conformed is coded with a number 2, but these numbers are completely arbitrary and don't actually have any numeric or quantitative significance, okay? So again, how do we conduct a one-way or one sample, oh my goodness, a one-way chi-square test? Well, we're going to go to analyze, just like we did with the one sample t, and we're going to go to non-parametric tests. Okay, so analyze non-parametric tests, and then we're going to go to legacy dialogues, and we're going to select chi-square. Okay, so analyze, non-parametric test, legacy dialogues, and chi-square. Okay. So we're going to go ahead and click. Right away, we're going to identify our variable, right? So the categorical variable, again, with both the one sample t and the one-way chi-square, we have a single variable. In the case of a one sample t, we have a single continuous variable. And in the case of the one-way chi-square, we have one categorical variable, okay? So our variable of interest is going to be whether or not our subject conformed at least once. Okay, so we're going to go ahead and move that into the test variable list. Okay, so now we need to set our hypotheses, right? And the hypothesis that we're interested in is the null hypothesis, okay? So in all of our examples in class where you guys were calculating your own chi-square values, the null hypothesis was that all categories would be equal, right? Whether it's the number of black and white cards in a deck or the number of ice cream cones sold. For those examples, the hypothesis was that the percentage would be equal across all levels of the category. But in this case, we have a slightly different null hypothesis, right? So in this case, the null hypothesis is going to be that the frequencies in our sample are identical to those in the population, right? And the population in this example is Ash's original study, his 1955 conformity study, right? So in that study, the values were 75% of participants did conform, right? Or 75% of participants were scored with a yes, right? And 25% were scored with a no, if we look at the original data, right? So what we're going to do is, instead of telling SPSS that the null hypothesis is that all are equal, all levels of the category are equal, right? So that would mean 50% of our sample conformed and 50% didn't conform, right? Which isn't what Ash found. So now we need to tell SPSS what our null hypothesis is. Okay, but critically, we need to put it in the correct order, right? Because for this particular variable, no is coded as 1, and yes is coded as 2, okay? So first, we need to put in 25% here, right? Because if 75% of the population, or of Ash's original study, conformed, then that means that 25% did not, right? And if they did not conform, they would be, the way that they would be entered into SPSS is a no, right? So that no is associated with a 1. So we need to go ahead and put 25 in here, and then 75 for yes. Similarly, right, if I collected a sample of Mercer students and I asked them what their political affiliation was, right, and it came back and 55% of my sample were Democrat, and 45% of my sample were Republican, right? If I wanted to compare that to the national average, right? So let's say there are, in a national survey of college students, there are 60% Democrat and 40% Republican, right? So I would know that I had slightly fewer. So I had only 55% Democrat instead of 60%. And I had a few more Republicans. So I had 45 instead of 40%. I would know that my values were different, but how would I know they were significantly different, right? So the way I would score it in SPSS is I would put, or the way I would enter my data into SPSS is maybe I would put a 1 for Republican and a 2 for Democrat, right? That's how SPSS is going to register the different levels, right? So if that was the case, then I would come and I would click, just like I did, I would go to Analyze and non-parametric tests and chi-square and all that. And instead of putting in a 25 and a 75 here, I would put in a 40% for Republican and 60% for Democrat. Okay, so that's all I'm doing. It's the exact same process, except instead of doing it by hand, I'm asking SPSS to do it for us. Okay, so then I'm going to go ahead and click OK. All right, so now we have our output. And again, our output is going to look very, very similar to what we came up with when we did this by hand, right? So I have the number of participants in my sample under observed in. I have the number of participants in my sample who either didn't conform, right? So I have 57 participants in Dr. Mori's sample who did not conform. And I have 143 of Dr. Mori's participants that did conform, right? Those are my observed values. So that's the data that Dr. Mori collected, right? And I can compare that to what I expect, right? And what I expect, my population parameter in this case, is Solomon Ash's original results in his experiment, right? So 75% of Ash's participants conformed, right? And that corresponds to 150 out of 200, right? Whereas 25% did not conform, right? So that's where this 50 comes from. 50 divided by 200 is 25%, okay? So what SPSS is going to tell us is whether 57 is significantly different than 50, and whether 143 is significantly different from 150, right? Because remember, the alternative hypothesis that Dr. Mori is making, the research hypothesis, is that we won't have the same percentage as Ash had in the 1950s in terms of the percent of people that conform. So Dr. Mori is hypothesizing that our number of people who conform, or the percent of people that conform, will be significantly lower than 75%. And the idea is that maybe people felt more pressure to conform in the 1950s than they do in present day, right? So that's what we're trying to determine, is whether Dr. Mori is correct, or whether the null hypothesis is true and the same percent of people conform nowadays than they did in the 1950s, okay? All right, so how do we know whether our sample is significantly different from Ash's sample or not, okay? Well, first, we have our chi-square value. Okay, and our chi-square value is exactly the same value that you would calculate by hand. But instead of having to look at our degrees of freedom and our chi-square value and go to our table to get a critical value, okay, like I said, SPSS always gives us our p-value, right? So whenever you see anything with sig or significance attached to it, pretty much in any table that you generate, that's your p-value, right? So our p-value is 0.253, okay? And our decision rule, as you know, anytime we conduct an inferential statistics test, is that if our p-value is greater than 0.05, then there is not a significant difference, and we accept the null hypothesis, or we retain the null hypothesis, right? So because 0.253 is larger than 0.05, okay, we retain the null hypothesis and conclude that, in fact, people in Dr. Mori's sample were not significantly different from Dr. Ash's original study, okay? So essentially, people were just as likely to conform, people are just as likely to conform nowadays as they were in the 1950s, okay? All right, so one more thing. Now that we have our results, is to write them up in APA style, right? And you're going to want to include your hypothesis. You're going to want to include any relevant descriptive statistics, so percentages, your chi-square value, your degrees of freedom, and your p-value, okay? And it's also nice to include your sample size, okay? So it would be something like, we hypothesize that our participants would conform less often than Ash's participants, 75% of whom conformed at least once, right? So there we have our expected percentage. A one-way chi-square test found that our results were not significantly different from Ash's results, and we report our chi-square value and our p-value. Contrary to our hypothesis, our participants were just as likely to conform as Ash's participants, okay? So just like we would include the mean and standard deviation of the population and of the sample, with one-way chi-square, you want to include the percentages from your sample and also from the population, okay? All right, so that concludes this tutorial video on conducting one-way chi-square tests in SPSS, and I will see you in my next video where I talk about conducting a two-way chi-square test. All right, I'll see you guys later.